So let's take a look at what those wave functions look like. Now, if you're going to plot a function of two variables, you're going to have to do a three-dimensional plot, right? So your z-axis would be your psi, and you have your x and y axis for your coordinates. So what we can do, let's do that on MathCAD. Here's a MathCAD document. Here I defined what a nanometer is. Here's the definition of L1, it's 1 nanometer. L2 is also 1 nanometer. For starters, we're going to assign n sub y equals 1 and n sub x equals 1. Here we define a range of index variable I from 0 to 100. We're going to calculate 100 points along the x-axis, and we're going to have 100 points along the y-axis using index j. So you can see x sub I starts from 0 all the way to L1. So x sub I is equal to 0 when I equals 0, and it's going to be equal to L1 if I is equal to 100. Then y sub j, our y variable, you also have 100 points there from 0. You start from y equals 0 to y equals L2. When j equals 100, y is equal to L2. Here's our definition of the wave function, the x component of the wave function, square root of 2 over L1 times sine n sub x times pi times x divided by L1. And here's our definition of the y component of the wave function, the square root of 2 over L2 times sine n sub y times pi times y divided by L2. And we said that our wave function psi is a product of a function of x, so big X of x, times a function of y. All right? So like I said, if you want to draw a three-dimensional surface plot on MathCAD, you have to define a matrix that's calculated at equally spaced points. So here we define A sub ij. Okay, so this is element I, this is row I, column j of matrix A, would be the value of psi at x sub I and y sub j. And when you do your surface plot in MathCAD, this is what you get for n equals 1. Notice this looks like a mountain right here. The red part right here, it's color coded, so the red part corresponds to high values of psi. You can format this chart on MathCAD. You'll notice here's the variable that we're plotting on this chart. We can format this by double clicking, and you can, for example, if you want to show contour lines on your graph, you can let me see, we can change the perspective by, you can rotate this, for example, by 15 degrees. Let's see what that looks like so you can see better. And so that's rotating it. And you can tilt it. Let's see what happens if we tilt it by 45 degrees. And that's what the graph looks like. So this thing right here is your x-axis, and that's your, okay, I think that one's your y-axis back there, and you have your x-axis over here. Okay, and then you can change the twist angle. Let's say you want that to be 90 degrees. Let's see what that does. Yeah, you got it twisted. So this is looking at it from the back. All right. You can, instead of a surface plot, you can also draw what's just a contour plot, and this is what you'll see. This is what you have in the earlier presentation. So you can see the circles here, I mean the contours, the lines correspond to locations that have the same value of psi, and the maximum value of psi occurs right here in the middle. Okay, so the red color corresponds to higher values of psi. Now let's see what happens now if we were to change our n sub x and n sub y. If you remember, if we make n sub x equals 2, you're going to get a node at x equals L1 over 2. And if you did that, Mathca is now recalculating. So this is your x-axis right here. At L over 2, you have a node. So you'll notice a maximum value, a red contour corresponds to high values of psi. That's high positive values. A blue contour here corresponds to low, a big negative value for psi. So you get a minimum right here on the right side and a maximum on the left side. You can format this to show the surface plot instead. So you can change this to a surface plot. And that's what the thing looks like. So you can see a maximum at L2 over 2, halfway along the y-axis, and a quarter of the way along the x-axis. You get that maximum, and then you have the minimum in your function on the other side of the box. Okay? So if you want to set n sub y equals 2, you're also going to get a node at L2 over 2, and let's see what happens when we do that. And this is what you get. So you have a node here at L1 over 2, and then you have another node at L2 over 2, at y equals L2 over 2. So your wave function changes from positive, goes to 0 at the node, goes negative on the other side. So every time you cross a node, your wave function changes sign. So in the blue parts of the box right here, you have a negative value for psi, and then the red part, you have that maximum positive value for psi. Okay.